Today we are going to continue the session what we are discussing during the last few lectures. That was about earthquake. Now let us imagine there is an earthquake. Okay, so point what you saw, it is an earthquake happens. So when an earthquake happens, we know there are two things. One is magnitude of the earthquake, and second one is the intensity of earthquake. So in this case, the magnitude of the earthquake, let us say it is 8. 8 is the magnitude. So that is some amount of energy which proportional to the magnitude 8 is released during an earthquake. But intensity of this earthquake which felt at the location of origin, we call it as epicenter. At the epicenter, the intensity of the earthquake is 10. You remember the Mercalli scale? It is 10. Now you imagine and you tell me what will happen in these three locations. What would be the intensity as point A? What will be at the intensity as point B? And what will be the intensity as C? Question is whether it will be more than 10 or it will be less than 10 or it will be same. In ideal condition, in normal condition, if the rock types are same, there are so many parameters which controls the intensity of an earthquake which happens in any location. But if I assume that all this location, if all the rock types are same at the point where it originates, and if it moves away from the location, then the intensity of the magnitude intensity of the earthquake is going to be reduced. Such as if it is A, which is away from the origin of earthquake, it will be less than that of 10. Then it far away from the origin of earthquake, it will be little more less. Then it is far away from the origin of earthquake, it will be much less than that of the point of origin. Okay. Now the similar way, if I am going to find out the points of all locations where the magnitude 9 is happened. So it would be something like that. Around the location from the epicenter, there are number of points would be there. The magnitude of, intensity of that earthquake would be 9. Similarly, there would be number of other locations where the intensity of earthquake would be 8. Similarly, there would be number of other locations where the intensity of earthquake would be 10, then 9, and this will be 8. This is the line which connecting the points of equal intensity of which earthquake? This particular earthquake. Okay, so these lines we call it as a isoseismal lines. So isoseismal lines are what? The line passing through values of same intensity in a particular earthquake record. The earthquake is only one, but intensity of that earthquake when it is moving away from the epicenter which reduces, and we are identifying the locations of equal intensity, and that is called isoseismal line. Similarly, in this case, this is isoseismal lines which connecting the points of equal what? Intensity. What about the magnitude of all this area? When it is moving away from, magnitude will change. Magnitude is not going to change for any area where you see for this particular instance of earthquake, the magnitude is going to be 8. It is not going to change. So this line we call it as a isoseismal lines. Okay. So this is an example of this Butch earthquake, and what you are seeing here is the isoseismal lines of this Butch earthquake. Now, second one is the important question, that how do we identify an earthquake location? Because in an event of earthquake, what it happens is a sudden release of energy. As a result, so much of energy will be released, and virtually the entire surface will be shaking. But how do we find that in which part this particular event originates, in where from this particular event originates? So identifying that event originating location is called locating an earthquake process, and there are two main processes by which we can identify the location of an earthquake. Okay, the first method is this. The same thing what you have discussed right now. We are identifying the isoseismal lines of that particular earthquake. Okay, and second, the lesser the intensity of this is increasing, then what would be the location of the earthquake? The location of the earthquake would be somewhere in the center. Similarly, there is one more method. That method is something like, you just imagine there is an earthquake. And you know what happens in an earthquake? There are two types of waves, P waves and S waves. And you also know that P waves moves faster than that of S waves. At an instance of earthquake, this is the point where the earthquake happens. So P waves and S waves will start moving on the surface. But what will happen to the P waves? P waves will be moving faster than compared to the S waves. Okay, so as a result, for an instance of 30 seconds, if I take after the breaking of the rock, the energy started releasing. That point we call it as an earthquake. Just after 30 seconds, when you see the location of these P waves and S waves, it would be something like that. The P waves would be little ahead of S waves. Because of what the reason? Because of the reason that P waves moves faster than S waves. Very simple reason. Correct. So it will be making a difference between the location where it reaches. So for instance, let us consider this is x distance, which is the difference between the P waves and S waves after a particular period of 30 seconds. So there is a earthquake happens. We wait for 30 seconds and we just observe that at 30 seconds where these earthquake waves are reached. So P waves reached at a point and S waves reached little back from the P waves. So that we call it as the difference between the locations where it reached as x. Correct? Now let us imagine another situation. Same earthquake happened. P waves and S waves are moving. I'm going to consider the location of P waves and S waves at a time of 60 seconds. Almost double than the previous case. What will happen in this case? P waves will be ahead of S waves. It will be the same difference or the difference will be more. Let us see. P waves and S waves started. So the distance between P waves and S waves is increasing. Why is it increasing? Because when the time is more, the speed or the velocity of these two things are going to be same. But when the time increases, the distances will also increase. Correct? So this is what we call it as a time duration 2x, and this is the one of the important concept of locating the earthquake from a travel time. We call it as the P and S wave travel time method. Similarly, if I take a third situation, here also this happens 90 seconds. So what happens? The distance between these three things are now much larger. So let us call it as a 3x location. Okay, so where is these things? It is locating at different points. So this things concept is clear. When the distance from the origin of the earthquake to the recording station it sees, so the differences between the arrival time of P waves and S waves will increase as the distance increase from origin of earthquake to the recording station. Okay, so if that concept is clear, now let us imagine a situation. There are three locations where we kept a seismograph. You know what is a seismograph? Seismograph is an instrument which measures the vibrations. And there is an instance of an earthquake. There is an instance of an earthquake, and I recorded the earthquakes at these three locations. So earthquake waves will come, and the location A, the seismograph will record the earthquake, and location B, the seismograph will record the earthquake. Earthquake C, the seismograph will record the earthquake, and we will be able to know that exactly at what time the waves reached there with precise measurements. We will also able to see that at what time the primary waves reached and the secondary waves reached. Now when I got this, I got that at A, the waves reached at with a difference of x between primary waves and secondary waves, and at B there were a difference between these two waves are 2x, and at C the difference between these two waves are 3x. So now you must have got an idea that location C would be far away from the origin of the earthquake, location B would be the intermediate, and location A would be the closest location of the earthquake. But how to find out the exact location? What I am going to do is that I am going to prepare a circle which is having a radius of x for the case of station A, and for the case of station B I am going to create a circle with a radius 2x, Now there are 2 points where it intersect, one here and another here. So by this at least we know that either of these locations the earthquake happened. But if I prepare one more circle with the time, with the difference time between these two, then finally I come down to the point, this one single location. So what I identify here, this is the epicenter of the earthquake when I measure the differences between the travel time taken by primary waves and the secondary waves. So this method we call it as a SP travel time method of identifying or locating an earthquake. Next topic is classification of an earthquake. So classification means earthquake will not tell you that okay, I am this particular earthquake, I am not that particular earthquake. But for the convenience of study, we classify the earthquakes into different categories based on different parameters. First one, it is based on the depth of focus. You know what is focus? Focus is the point at which the earthquake originates. This is the point below the surface of the earth where the earthquake originates. So at what depth the earthquake originates? Based on that, we have a shallow earthquake, or we have an intermediate earthquake, or we have a deep earthquake. So shallow earthquakes will be at a depth of around 60 kilometers below the surface, and 60 to 300 we call it as intermediate earthquake, and 300 to 700 we call it as a deep earthquake. Similarly, there is one more method. We classify the earthquakes based on its origin. Origin means that what is the cause of that earthquake, what really make that earthquake. So there are basically two types. One is non-tectonic earthquake and another one is tectonic earthquake. Tectonic processes we have discussed already. So the movement of plate, the lithosphere over a plastic layer of asthenosphere, and its subsequent collision or separation that actually creates pressures on the boundaries of this earthquake zone, the plate boundaries, and that creates breaking of the rock. We call it as a tectonic earthquake. But other than that, there are a number of other reasons. Number one, it is a volcanic eruption, because when the volcanoes which erupts, so that is a huge amount of material which is coming out from the mantle or from the subsurface. So that creates some amount of shakes in the surface. So we call that is also a earthquake. Collapse earthquakes, it is basically the landslides or the mass movements. If you imagine that a large part of a hill is moving downward, so that amount of load which is moving downward, and that movement will actually create some amount of vibrations on the surface of the earth. We call it as a collapse earthquake. And the reservoir induced earthquake, we discussed when there is a reservoir, water stored in the earth, the reservoir will exert some pressure on the bottom portion of the reservoir. So that is going to be a rock. So these rocks are sometimes will create a break that will create the earthquake. And the third one, it is the classification based on the magnitude of an earthquake. And if the magnitude of earthquake is more than 7.8, we call it as type A or class A. In 7 to 7.7, we call it as class B. And 6 to 7, we call it as class C. And 5.3 to 6, we call it as class D. And class E is less than 5.3. So these are the main classification schemes we apply for the an earthquake. Now the next topic, I wish that it is the effects of earthquake. Okay, so earthquake means it creates a lot of headache for the peoples. After an earthquake, it is really trouble for the humans, because the building collapse, the network connectivity goes, electric lines failure, water, food, that all our basic needs are going to be damaged after an earthquake. So based on that, what kind of effects this earthquakes done to the human or in the natural environment, we classify effects into two categories, which are primary effects related to the origin of earthquakes. Because of the earthquake, there are number of changes which happens. Number one, it is a change in the topography, because there is a break in the rock. As a result, there may be some places, there may be some elevations. New water courses may start. Okay, so river may change its path and it may go to new channels, and new channels can be originated by the process of an earthquake. Formation of small hillocks we can expect after an earthquake. Change in direction of existing course of river flows, water course. So water or river flows that also can change the course. So wrapping of strata means it will fold. The soil on the surface will fold, or it will wrap one another. So that kind of wrapping, and as a result, there would be change in the topography, or there would be a change in the formation of small hills can happen. Formation of sand dikes. Sand dikes is nothing but there is a surface. So there is a layer of sand, and as a result of earthquake, the sand will liquefy and the sand will come to the surface. So this becomes a sand dike. Okay, so it is cutting across. So this is as a result of liquefaction, because sand which is present below in the surface, that is under high pressure and which is confined. But at the point when it get a chance to break, so that breaking will squeeze the sand and it will start its movement towards the upward direction. And as a result, this kind of sand dikes can produce. So huge cracks on the land also can produce. Change in underground water level is also can be expected as a result of the earthquake. So this all we call it as the primary effects of earthquake. And there are secondary effect. This is because of the passage of the earthquake waves. Because when the earthquake waves moves on the surface, it distract the buildings, it distract human-made things, so that our lives are getting affected by the earthquake. Landslides and mudslides, we have seen that mass wasting. So landslides can be produced by a vibration on the surface or as a result of an earthquake. Destruction of multi-storied buildings. So buildings may collapse. Dams and bridges can be collapsed. Uprooting of the trees can be happened. And there are always a psychological effect on human beings, because there are so many people who are closer to you or your relatives who get affected by the earthquake, so may get seriously hurt or may have died. So that creates a lot of psychological problems also in the human for the humans. Communication systems are always going to get hurt because of the failure of underground power cables, or the electrical cables, or the telephone cables, or the distraction on the satellite communication systems or the receivers. So these all things are going to be get affected. The roads, railways, telephone, TV, everything is going to get disturbed after an earthquake. So this all we call it as the secondary effect of earthquake. Then there is a chance of tsunami. Tsunami is also associated with the earthquake. Earthquakes will produce large waves. Normal waves, what we see on the sea, you see on what you observe on the sea, maybe of around a height of 9 meter or 10 meter. But at the point when there is a tsunami, the height of the sea waves which goes around 90 meters. So this huge waves of tsunami waves which enter into the coast, and it damages the entire coastal region. So that is as a result of the earthquake waves. Liquefaction of soil and the sinking of structure is common after an earthquake. And fire due to damage of gas lines is also an effect after the earthquake. So seismic zonation of India, that what does it mean? As when we see our Indian subcontinent as a node, there is around 54% of our total area of India is prone to have earthquake damages. Is depending upon number of parameters. Number one, it is the rock type of that region. Number two, it's the tectonic stability of that region. Number three, the structural features. Okay, so the number of other parameters which together decides that whether this area is going to have a earthquake, or which magnitude and intensity earthquake can happen in one particular region. So accordingly, our whole Indian subcontinent is dividing into 4 different zones. Okay, so it starts from zone 2, which is having the minimum chances of having high magnitude and intensity earthquake, to the zone 5. So the zones from zone 2, zone 3, zone 4 and zone 5. So if in this map, if you see, the zone 5 is located basically on the Himalayan regions, 1, 2, 3, 4, 5. Then one part is here in our Kutch region. This is the basic locations where the zone 5 is considered. And zone 4, there are three major regions. So one is here in the Gujarat itself. Then is the major stretch is in the Himalayan terrain. Then some portions are there in the western part of our India, and some portions is on the eastern part of our India. And the zone 3 is basically covering our mainland of Gujarat and this whole area. And zone 2, that it is having very less chances of having an earthquake, is basically covering the peninsular India portion, that is from Tamil Nadu, Andhra Pradesh, and all this region, which is composed of basically older rock types. The rock type which was formed in the last 500 million years before. So that kind of rock types are existing on this part. As a result, it becomes considered to be a stable portion, and there are chances of getting earthquakes are less. So this earthquake zonation map will help a civil engineer to decide, while taking the design parameter, what earthquake zone index parameters to be taken. So that you will refer the IS code and you will practice that in your future higher studies. Okay, so we are going to see that what are the major cities which are covering in these different zones. For example, if I take the zone 5, the major cities located are Bhuj is in Gujarat, Imphal, Guwahati, Kohima, Tezpur, Manti, Srinagar, and Darbhanga. So these are the major cities. I just plotted randomly some cities which are located in the zone 5. In zone 4, Delhi, Amritsar, Ambala, Chandigarh, Patna, Simla, Ludhiana, and Roorkee. This is Roorkee. So these are the major cities which is located in the zone 4.